Okay, we're gonna skip this first one because that one is really complicated. We'll save it after we practice a little bit. Let's try this one. So looking at the right-hand side, I can see that there's a bunch of sines with different degrees and a cosine, one cosine. And then on the left, I have sine squared cosine to the fifth. So that tells me that every cosine has to go except for one cosine. So that kind of tells me that I'm going to change this cosine fifth from cosine fifth to 4 and then 1 cosine. I recall that sine squared plus cosine squared is 1. So that means cosine squared is 1 minus sine squared. Okay, since I have 2 cosine squares because it's cosine to the 4th, let me try that and see where I get. Okay, at least I change everything to sine only except for 1 cosine. Let's try to multiply them together and see where we get. So this is where you want to just use your foiling skills really quickly in your head. If you can't see it, this is basically 1 minus x squared times 1 minus x squared. Okay, so just foil in your head, square the first term, square the last term. That's going to give me a plus sine to the 4th. Take the product and double. So that's going to be minus 2 sine square x plus. Okay, look at the target. I think I see it. As long as I distribute the sine square, I am done. Okay, that's it. So let's go ahead and just have you start on homework because the other ones are gonna get pretty tricky and we'll practice that tomorrow. So this is page 10. This is the proof we skipped. All right, so what should we do on the left to get it to the right? Anything you want. Maybe change this cotangent square. Cosecant squared minus 1. Okay, now what? Yeah, so we can factor that. Okay, and then we can see that this is going to cancel. And then we get to cosecant u minus 1. That does not look like we are ever going to get to the right-hand side. So this is what happens. You're stuck. And you have to do crazy kind of roundabout thinking to get to the right-hand side, which is going to be a little bit too tough. So what we're going to do is change the right-hand side. Temporarily, we cannot actually say the proof, we can't change the left-hand side, get to this part, and then change the right-hand side, get to the same part, and then say they're equal, of course. You could do that, basically just say, like, get to the point where it's 0 equals 0 if you are doing that. So, no, you cannot do that. However, we do want to see what's going on the right-hand side because I can't finish. So here is kind of my analogy. So, all right, every year I do this analogy, and then people are like, some people understand what I'm doing. Some people are like, I don't know why you're even talking about this. Okay, so remember when you're, like very little and then you have something like this and then you don't have to draw this. You were playing with a maze, right?
I like how you made this so fast.
I'm sure you can too. It's a very commonly, yes, has skills. Anyways, and then let's say this is the beginning of the route. And then this is the exit. And let's say that you started and then, you were like 3. So you were not that great with finding the solution to this. And then you got to this part and you said, oh no, I'm stuck. what do?
You go in from the other side.
Go in from the other side, because you're like, how am I supposed to get to the end? Oh, I realized I could have just went like that. So what you're going to do is the same thing. You're starting this maze of proofs from the beginning. And then you got to a point you are stuck. So how do you get to the exit? You start from the exit. You start from the exit, you go to a point where they're meeting in the middle, and you said, oh, that's how you do it. That was easy. So then you just go back from the beginning, and then you go to the end. Does that make sense? It's like looking at a cheat of a video game or something. Okay, so what you're going to do is you're going to start at the end of the proof. Okay, so and we're trying to see where it's going to meet in the middle, cosecant u minus 1. All right, so what should we do on the right-hand side?
Maybe change everything to sine and cosine.
Yeah, maybe change everything to sine, cosine. So cosine u over sine u times 1 over cosine u minus sine u over cosine u. Okay, then what? Okay, all right, let's multiply it together, and then you get 1 over sine u minus 1, which is cosecant u minus 1. Ah, they're the same. Does that make sense? No. No. What happened? Okay, so cotangent is cosine over sine, secant is 1 over cosine, and tangent is sine over cosine. So then when we distribute, the cosine is going to cancel. We have 1 over sine. This is exact reciprocal, so that's just 1. So then 1 over sine is cosecant. Okay, so now they're exactly the same. I know how to get here. I can't leave the proof like that and say that, oh, both sides are equal. So what I'm going to do is recopy. Does that make sense? I'm going to copy this, put it here. Copy this, put it here. Amelia's like, I didn't know you can do that. So yes, you still have to show the proof, right? You can't figure out how to go there directly. You meet in the middle and then recopy it. Okay, all right. Some of you are still like, I don't know what I'm supposed to do. Okay, the next step is going to be 1 over sine u minus 1, because that's just this step. Does that make sense? I'm going this way. Okay. Okay, and then the next step is this step that I don't think anybody would be able to figure out on their own. Right? This is quite complicated. Nobody's going to think in that direction. But now that we figure out the answer, we're going to do that. And then the answer is cotangent u times secant u minus tangent u. All right, done. So then we just kind of erase this part, which I cannot do for some reason. And then as if it never happened. And then I got to the proof the way I wanted, as if I had no trouble. But you had no idea that I didn't know. And I was just trying to make them meet in the middle and rewrite. Okay, so sometimes when you don't know what to do with a proof, this is kind of a technique you use to solve. Who's still not understanding the technique? You guys are all okay? Yes. Okay, all right. So today we are going to learn some more formulas. And along with formulas, that means you're going to use those formulas in proofs. Okay, so 5.3. All right, first question. Does cosine x plus 3 pi equal cosine x plus cosine 3 pi? All right, talk to your partner. Are they the same? All right, how many people say yes, they're the same? How many people say no, they're not the same? Okay, no, big no. Okay, so if you said it's the same, you're basically distributing, right? So let me kind of talk about distribution. The only time you can distribute is when it's linear. It's a linear function. Then you can distribute. Cosine is definitely not linear. You've graphed it last chapter. You know it goes up and down like that. When it's not linear, you cannot distribute. Okay? So there are very, very little things in life that you can actually distribute. So no, big no. So then how are you supposed to figure out the answer? Well, you need these formulas. Sum or difference formula. Okay, so this is how it works. So sine of one angle plus another angle is going to equal, so we're going to use u and v. Sine of u angle plus v angle is going to be sine sine u cosine v plus cosine u sine v. I'm going to tell you how to memorize this in a very quick way, but for now, just write it down. If you have sine of this angle plus that angle, you cannot distribute. You have to use this formula. Sine u cosine v plus cosine u sine v. Okay, what if you have to subtract them? Then that is u minus v. Okay, you're going to take the same formula, sine u cosine v, and then this time you're going to put a minus there, cosine u sine v. But most of the time, they do not write it this way in your book because it's just too much to write. And we could condense two formulas into one big formula by just doing this. So you see how if you are adding the two angles together, your formula would have a plus, right? If you're subtracting the two angles, you have a minus. So the way that they would actually write this formula, instead of writing two formulas, then what they would do is they write plus minus and then plus minus. It does not mean choose either one, or like when you square root something you have plus minus. That's not what it means. It means if you're going to use the plus version of adding, you're going to use the plus. If you're going to minus, then you use the minus. Does that make sense? Okay. All right, we have another formula. So if it's cosine of u plus minus v, this formula is different from the sine formula. So if you have plus minus, meaning if you are adding, you're going to use the other one. If you're going to subtract, you're going to use the one of the other one. It's going to be cosine u cosine v minus plus. So when you're adding the two angles, you're going to actually minus. If you're subtracting the two angles, you're going to use plus. And then sine u sine v. All right, that's pretty hard to remember. So I'm going to teach you guys a chant. Okay, first, bless you. In math, whatever you want to memorize, you should try to find a pattern. So on the sine one, can you guys see a pattern? Sine, sine, cosine, cosine, sine. And then what about the bottom one, the cosine formula? Cosine, cosine, and then sine and sine. Okay, so this is what you're going to memorize. Sine. I'll write it without the E. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine, sine. Okay, so you say sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine.
Whoa.
How does that work? You start with sine, so that is the sine formula. Okay, sine, cosine. Let me just show you. Okay, first copy down the chant, and then I'll show you how that formula works.
Wait, does that say sine?
Yes, S-I-G-N.
Oh.
Okay, so this is how it works. Sine, cosine, cosine, sine. Cosine, cosine, change the sign.
Oh.
Sine, sine. Okay?
Sine cosine.
All right, so everybody must say it with me or else you cannot memorize this formula. It's too crazy. Okay, 1, 2, 3, go. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, one more time. 1, 2, 3, go. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, good?
This sounds like this sounds like a better.
That's cold.
Using
Okay, all right, last one, tangent. So if you have a tangent of u plus or minus v, this one's pretty easy. Just remember it's sine over cosine.
Oh, that's it?
Yeah, that would be the fastest way to memorize your formula. Tangent is sine over cosine, even when the double angle, the sum and difference formula is the same. Yeah, you had to plug it in, but at least you know what it is. It does have its own formula. Basically, it's kind of a simplified version of it. I'm just going to give it to you just in case you need it. Tangent u plus minus tangent v over 1 minus plus tangent u tangent v. You can always just memorize sine over cosine for tangent. That should always work.
Minus plus. That's a 1.
Yes, on the bottom it's a minus plus. Yes.
So it says cosine.
Tangent?
If it's cosine u plus v, then would it be cosine u cosine v minus?
Yes.
Okay, so
That's why you have a cosine, cosine, sine, sine, sine.
So that's why it's like minus plus. It's like plus minus.
Yes.
Wait, how do you know the signs? Like, why is it minus plus?
It just is. It's a formula. Okay, let us use the formula. Okay, so let's find the exact value of cosine 15 without calculator. So cosine 15 is not in our unit circle, so we can't really know the number, but we can use our sum and difference formula to help us. So first, you have to think of cosine as if it's an angle plus an angle or an angle minus an angle. So which two angles adding or subtracting gets you 15 degrees?
45 minus 30.
Yes, 45 minus 30. All right, this is the cosine difference of an angle formula. So sine, cosine, cosine, sine.
Cosine, cosine, sine, sine, sine.
Okay, cosine, cosine, sine, sine, sine. So you're going to do cosine of the first angle, cosine of the second angle. Sine reminds you to switch the sign. And then sine of the first angle, and then sine of the second angle. Okay? Yes? Questions on how to apply the formula?
So basically, like whenever it's minus over there, then it will be plus on.
Yes, for
So
cosine,
switch.
because cosine, cosine, sine, sine, sine. All right, now we're going to actually evaluate. What is cosine 45?
Radical 2 over 2.
Radical 2 over 2. What is cosine 30?
Radical 3 over 2.
You're the unit circle master today. Okay, what is sine 45?
Radical 2 over 2.
Radical 2 over 2 and sine 30?
1/2.
1/2. Okay, let's review some algebra. Square root 2 over 2 times square root 3 over 2 is what? Square root 6 over 4. Okay, radicand times radicand. Square root 6 over 4 plus square root 2 over 2. Add them together, again, algebra review is what?
2 times 6 over 4.
What? Oh, wait, I wrote this wrong. Sorry, this is over 4.
Oh, okay.
Oh.
Yes, so then what is it?
6 plus 2 over 4.
Good. Okay, I'm glad nobody says rad 8. You cannot add the radicands together, okay? Okay, this is the answer. Cosine 15 degrees. All right, let's try another one. Sine pi over 12. Pi over 12. You're probably like, what is pi over 12? There are two things you can do. Either figure out which two radian angles will get you pi over 12, or change pi over 12 into your degrees and then think in degrees. Because you're probably faster in degrees than radian. Okay, what is this in degrees? Or what do I need to multiply by to get it into degrees?
180 over
Okay, 180 degrees over pi, good. 180 divided by 12. 15, thank you. So this is also 15 degrees, but we're gonna do sine of 15. Sine of 15, so which angle and which angle? 45 and 30 again, so sine 45 degrees minus 15 degrees. You're gonna, again, remember, sine, cosine, cosine, sine. Okay, go ahead and figure this out. Let me know when you are done. So the answer is square root 6 minus square root 2 over 4. Okay, now we're going to go backwards. So it says rewrite them as a sine or a cosine of just one angle. So what you're going to do is they're just trying to see if you recognize the formula. So the first one, which formula is this for? Is it a, huh? Sine, because you see sine, cosine, cosine, sine. Okay, so then this will be the sine of what angle, and is it adding or subtracting or adding? Okay, so 22 degrees plus 13 degrees. So this is going to be sine of 35 degrees. And that's it. They actually don't want you to evaluate. They just want you to write it as a sine or cosine of an angle. Okay, so let's have you try B and C. So B, you can see this is cosine, cosine, sine, sine, sine. So you know that this is going to be cosine of pi over 3 minus pi over 4. A lot of you change it into degrees, but I want to make sure that you can do this without changing things into degrees. Just multiply by 4 over 4 here, and then 3 over 3 here. So that's going to be a 4 pi minus 3 pi all over 12, which is going to be pi over 12. Cosine pi over 12. See, you can see that this looks like cosine, cosine, sine, 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 but it's sine, sine, cosine, cosine. So we're going to change the direction. So this is going to be negative cosine x, cosine 2x, plus sine x, sine 2x. This is still not cosine, cosine, sine, 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 because there's a negative in front, so we need to take out the negative. When you take out a negative, you have to factor it out and change this sign. Please be careful of that trick. Okay, so now we have a cosine, cosine, sine, 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 so that's a negative cosine x plus 2x. So this is negative cosine 3x. All right, now that we know how to, apply the formula, we're going to use this formula in proofs. So adding on to all the stuff that you have learned. So you have learned the Pythagorean stuff, you have learned the odd and even, you have learned the cofunction angles. Now you're going to add the sum and difference formula into your repertoire of proof tools. All right, let's try this one. First, cosine pi over 2 minus x equals sine x. Is that true?
No.
Think about like 4 days ago, maybe. Was that? No, no, remember.
I know.
5.1.
I know. It looks like that sign is not equal to sign. Wait, it's true. It's true.
It's true. That is one of the formula you had to memorize. Pi over 2 minus x. Sine and cosine are cofunctions. So that's true. But they do want us to prove, so here's how you're gonna prove.
So what is it asking
You
us?
see how on the left it's a cosine of angle minus angle. So we're gonna use the sum and difference angle formula. Okay, so cosine sum and difference formula is what? We just memorized it. Cosine formula is,
Cosine, cosine, sine.
yes, cosine, cosine, sine, sine, sine. So let's go ahead and use it. Cosine, sine means change the sign. Sine, sine. Okay, and what we're doing is we're trying to make it match the right-hand side. Okay, the next thing we're going to do is evaluate. What is cosine pi over 2? 0. So this is 0 times cosine. And then what is sine pi over 2? 1. Therefore, it is sine x. Yes? No? Okay. Let's have you try one yourself. B. Okay, so for C, you do want to use the sine over cosine formula. I think it's faster than the tangent formula. The tangent formula, you get to a point where it's undefined and it gets a little crazy. So you could just change it to the sine over cosine and then use the double angle from there.